Okay, so we are at week 9. Week 9 is lots of fun. We're going to talk more about lists. This last one should pretty much make sure that you understand it. So what we're going to talk about today is yet another kind of a queue. I mean, not a queue, but we're going to make a queue out of it actually. So first of all, what was a queue, remember? What's a queue?
Like first in, first out. Inserted in order.
Last in, first out.
Yes.
Is that it?
No.
No, first in, first out. That's right. First in, first out. It's a line of people. Last one comes at the end. First one leaves at the front. Okay? We did this with arrays. And you saw it's basically just, we get an array, we put it inside of a class and restrict the operations that we can do to that array to only be able to add to it from one side and only be able to remove from it from one side. And I told you that we could do this kind of a stuff with linked lists, and today we're going to do it with a linked list. We're actually going to do a priority queue. And what was a priority queue? Damn it. Yeah, that's what a priority queue is, where things are in certain order, right? So it's like an array that is in ascending order or descending order. So every time you insert something in the queue, you got to make sure that it goes in the right place. So we're going to do that. So before we get to that, let me tell you about a double-ended linked list, right? So what is it? Why is it double linked? Well, you have a next and you have a previous, so every link points to the one before it and the one after it, right? So it's got two fields of the link type that are part of each link so that they're connected back and forth. If you did the assignment from the previous week, which was the circular list, right? The circular list asked you to delete a specific link, remember that? And in order for you to delete a specific link, let's say I want to delete link number 7, right? I actually have to, I need to be able to kind of stop at one link before it, because the only way for me to delete this link is to connect this previous link to the one after it, right? And we can't really go back in a single linked list. But in a double linked list, we could stop at the link that we want to delete, and we can tell it, okay, we'll go back one, and then connect the one from before to the one after. Okay, so it's kind of, in a way, it kind of simplifies things, having two links or having a double link. But in some ways, it's a little bit more complicated. Okay, because you're going to have to, every time you delete something, you're going to have to establish two connections. You have to tell it, okay, connect. So if we're going to be deleting this one here, we're going to have to connect the one before to the one after, and we're going to have to connect the one after to the one before. Okay? And it might seem a little complicated, and it is a little bit complicated the first time you go through it, but if you do it a couple of times, it becomes very easy. Okay? So the more you do it, the better it is. So let's have a look at the double linked list that I have in here for you, and have a look at what that thing is going to do. Okay. So and other than it being a double linked list, meaning that we're going to have a next and a previous as part of each of these links, you also have a reference to the first and the last, right? So before we had a regular list which had a first, now we have a double-ended list which has a first and a last, which is easier for us to implement a queue using a first and last, right? Because you always want to remove the first. You always want to remove, add at the first, remove at the last, or however you want to, consider it. But it helps to be able to jump directly to the first and the last in this particular case, right? So if we're going to do a queue, it really makes sense to make it, to have a first and a last. Okay? So, looking at this here, all right? I have a class. So what is this going to be? Well, we have a class, call it link, call it double link, whatever you want to call it. All right. It has two fields of the link type, and it has a data, right? We're going to have a constructor. The constructor is going to make my data field equal to the new data, whatever the user decides to put in. And then we're going to make the next and the previous both equal to no. Okay? The next thing we're going to do is we're going to create a class called double-ended list, which is going to have two links, one referring to the first, one referring to the last. Okay, and then a constructor that goes with it, which creates the first and the last equal to no, and that's basically it. That's how it starts. If you wanted to create, start the whole thing from the main, this is it right here. Okay, so we have not added anything else other than just constructors at this point, and inserting at the end. So the way I would handle this thing, and it's slightly different than how you would do it from a circular list, which didn't have a first and a last. But it makes sense for us to create methods that are going to insert specific links at the beginning or at the end. Okay, the assignment I think asks you to implement those. So you could write one big function or method that inserts anywhere you want, but it would really make sense for us to implement a couple of more links in there. What I would recommend is have a method that inserts the initial link. If you don't have if you don't have any links, which is basically the first and the last are both equal to no, then the first time you're going to be inserting the initial link, all you got to do is say, okay, well, first is equal to the new link, last is equal to the new link, and that's it. It's very simple, right? And if you're inserting any link after that, if we're going to talk about a priority queue, you still want to have insert first, insert last, right? It will simplify things for you to once you're creating the insert and order method. Okay, so all it is let's say in here we're going to insert at the end, right? So at the end we have the last link points to no. Next is no for the last link. All we have to do is we have to say, okay, well, first your last link next is equal to the new link, and then the new link next is equal to no. And you really don't have to do that, because as soon as you create a new link, it automatically creates on previous and next equal to no. Okay, so you don't need to change the next. And this actually shows you how to do a single link list. This one doesn't really show the previous and the next. So this is just a double-ended. This is just a double-ended picture of a double-ended linked list. Okay, so in reality what you have to do is you have to, let's say we're inserting a new link, right? We're going to insert this new link. The first thing I need to do is I need to connect this old link to the new link. The next thing I want to do is I want to connect the new link previous to the old last. And then the next thing, third step I have to do is I have to tell the last, okay, now connect to the new link that's going to be the last. Okay, in other words, last equals new link. All right, so again, last refers to this link right here. So first thing I'm going to do is I'm going to change last.next is equal to the new link. Then I'm going to say new link dot previous is equal to last. So now it's going to point to this one, and then I have to tell her, okay, well now last is equal to the new link, and now last moves to the last one. Okay, so that's how we're going to do it. And there's more pictures in there. Insertion. So let's look at a picture of how you're going to insert the first. Kind of a similar thing. Okay, so this was my old first link. In other words, first and this link are basically, first and this link are equal to each other. So if I change one, I change the other one. So it's a convenient way for me to change this link through first. So the first thing I'm going to do is, okay, I'm going to say, all right, I'm going to make a new link. This is my new link. The first thing I'm going to say is I'm going to say, okay, well, this one previous, my first link initially, previous is equal to what? No, right? So the previous on the first link is no. The next on the last link is no, right? So the first thing I'm going to do is I'm going to have to change, okay, well, previous now is going to equal to the new link. That's what that arrow is here, right? So now first we change previous is equal to the new link. Then we're going to have to say, okay, well, new link next is equal to first, right? Now we're establishing the second two, this line 2 connection, right? So in other words, this one now points to this old first link. And then the next thing I have to tell it, I just have to say first is equal to new link. And now the first moves one down or one to the left. Make sense? I hope it will make a whole lot more sense once you do it, and really helps if you draw the pictures. Okay, current last, if it's a new link. Okay, deleting a link. So deleting a link is actually relatively easy as long as you can keep track of what's happening. Okay, so this is my link that I'm going to be deleting, right? The link before it is referred to as current previous, right? If this is my current previous will be this link. The link after is going to be current next. So what I have to do is I really kind of have to just connect this link to this one, and I have to connect this link to this one. I actually also have to delete this. Since this is C++, you have to delete the link. In Java, if you have a link and nothing refers to that link, the Java garbage collector will automatically wipe it out of, will free the memory eventually at some point once it realizes that nothing refers to this link. But the memory is not being released automatically in C++, so what we're going to have to do is we're basically going to have a link called current or whatever you want to say, and then we're going to have to delete that current once it stops at this particular link. You might think, let's say this is my link 1, this is my link 2, this is my link 3, this is my link 4, right? I have 4 links. Then I'm going to make one new link called current, which is equal to the first one initially. So now I have basically 5 links, right? If we added, the current which is just going to be equal to all these different links. So my question to you is, if I'm going to be deleting current, how is that going to delete the link that is already existing? In other words, I had 4 links before. Now I created a new link called current, which is going to stop at the one that I want to delete, and I'm going to be deleting current, right? How is that going to delete this link? Don't know? That's okay. Because the delete command, remember when I say current is equal to this link, we basically have a pointer. The current points to the memory address of, let's say this is link 2, right? Link 2 also is a pointer which points to some memory address. So we have 2 pointers that are pointing to the same exact memory location. So when I say delete current, I'm actually telling it free up that memory address that was being pointed to by both of these links. So if I delete one of these, I delete both of them. Okay? So now you know. Okay? But all you have to do is really you have to say, okay, well I'm at current, and I have to tell it current.previous, which is this link, .next is equal to current.next. Right? And then my current next.previous, which is this field right here, is equal to my current previous. And then, of course, I have to do the delete at some point, and then reduce the number of links, maybe, if I wanted to.
So they become the same, the current previous and the current next? They connect?
Current previous connects to the current next, current next connects to the previous. They're not the same, though. Yeah, they're 2 different links.
Okay.
And then we delete the actual current, which frees up the memory location for the current and the link that we're trying to delete. But in reality, we just have to connect 2 different things, and that's it. Okay, so where before, when we had a single linked list, you had to stop at the previous one so that you can connect the previous to the next, and the next didn't have a previous itself. In here, you can just stop at the link that you want to delete and then just delete it. Yeah.
Michael,
What's up?
I should know this, but once you delete current,
Yeah.
what is current?
Current was initially a link, so we're going to make a link current.
Well, once you delete current, what is there? Does it default to what was current.previous?
Current is gone. Current,
there's no current
yeah.
sign.
Well, there's no current. Yes.
Okay.
Once you delete current, current's gone, and the link that it pointed to, it's also gone. So they were both. I mean, technically, the current variable, I guess, still exists, but it doesn't refer to a memory location. Same thing with with the link that you're trying to delete. So that's all you really need. You just need to free up that memory so that the operating system can use it for whatever else it wants. Okay. And linked list efficiencies, right? So insertion, deletion is a lot faster than doing it with arrays, and that's what we're doing this for. Okay, so I don't know if I put any pictures in here. I might have. Double linked list. Probably I didn't. I think I did it. I wonder where I put it. Solution P8, P9. See if I drew some pictures on this thing. I'll be pissed if I didn't. Nope. Damn it. I keep drawing these pictures. I don't know where I put them. I'm gonna have to draw some more for you today. Anyway, let me go look at the Java class. Huh? What is this? This is I created my display link. Shows you. Yeah, I'm gonna have to simplify this too, just like I did with the Java class. So let me just show you just a quick example. I'm improving these every semester. I'll just give you an idea. Let me show you the Java double link, double nested thingy. All right, so this will give you some idea of how to do things, right? So I have insert left, insert right, insert ascending, delete link, delete first, last, right? So let's have a look at these real quick. All right, and so if I'm going to be inserting my first link, right, this thing is originally empty. All I have to do is I make a new link, right, and I make my first and the last equal to that first link. Okay, this is if I'm inserting left and there were no any new links, right? Now, if I wanted to, I can also, let's say this is my from before. I had one of these, right? I'm going to be inserting a new link now that this thing is not empty, right? So if it's not empty, what I have to do is I make a new link. This is my new link, right? I have to tell the new link next is equal to my old first. That's what this thing here is doing, right? So I'm establishing this connection. Then I have to do first previous is equal to new link. So now I'm establishing this connection that I have marked in yellow here. So now both of these are connected, right? So first, the old first is connected to the new link is connected to the old first. And then the next thing I have to do is I have to move my first link. My first used to be here. Now I just have to say first is equal to the new link, and now I have moved it, first is here, okay? Let's say we want to insert another link, so I'm going to be inserting another third link, right? From before we had this set up. The first thing I have to do, since this thing is not an empty one, hey, that's Richard's writing. I have to do new link.next is equal to first, so I'm establishing this connection right here, right? Then I have to say first.previous is equal to the new link. I establish this link right here. And then first is equal to new link. Now we have moved the first here, okay? And it really makes a whole lot of sense if you write it out just like I did, so that you can keep track visually in front of you how this thing works, right? So this is inserting the left. Inserting right is similar. Again, I suggest you start this thing with just an empty link, an empty list, right? So initially there's no links. We're going to make a new link. The list is empty, right? Since the list, and how does the empty work? The empty is just like a Boolean, empty, return, right? First equals null, and last equals null, right? So if first and last are null, the thing is empty. And if it is empty, you just basically make the first and the last equal to the new link. That's basically as easy as that other one that we just saw, right? Same exact thing. Now, if we're going to be doing a new link now, after we have this set up, right, this is my setup, and I'm going to be inserting a new link. The new link initially is null and null because that's how I set up the constructor. What I have to do is I have to tell it, okay, new link previous is equal to the last. So now I connect this new link to this one. Then I say last next is equal to new link. Now I have established this connection, right? And by the way, if I change this one here, that also changes all these other ones here. All right. And then the next one is I just say last is equal to the new link. And now I move the last from here to one to the right. So now it's connected. Another setup possible is, let's say we have two links already. First and last are connected to them. We're going to add another one, link 3 again, which is the new link. right? New link previous is equal to the last. So I establish this connection. Last dot next is equal to the new link. I establish this connection, right? And then the next one is I say last equals new last equals new link. Now I have moved the last all the way to the right. Okay, and that's how it works for pretty much every other link after that. So I suggest you do it a couple of times, like 2-3 times, to see how it works, and that should be good enough. So this is the insert left, insert right. Now we're going to do insert ascending. So that's why I recommend you do these first two, the insert left and insert right, because that will make insert ascending easier. Okay, how is the insert ascending easier? Well, first of all, if the thing is empty, right, you can call either insert left or insert right, or I actually would create a new function or method called insert initial, which just inserts the initial link, which was basically what we saw right here. This was my insert initial. I would put this in its own function, right? So insert initial just does this. First is equal to new link, last is equal to new link, right? So if it's empty, we do that. Now the other one is, let's say I have a bunch of links here. So this one is, I have a 10, 20, right? These are my links. I have a 10, 20, 30, right? If I was trying to insert the number 5, where would that go? At the beginning, right? So we'll go before this one, correct? In other words, if this is already a priority queue or a linked list that is in order already, which we're assuming that that's going to be the case since we're designing a priority queue, right? I have to insert if the data of the first one is bigger than the data that I'm trying to insert, then I'm going to insert left. Make sense? So that's what I'm saying. So if my first data is bigger than the new value, I'm going to insert left. So the first one is if it's empty, just insert initial. Else, if the first data is bigger than the new value, you insert left. And that's why it helps to create these first, so you can reuse them and use them the right way.
What if it was less than the value? Would you put it just right next to it on the right?
What do you mean?
Like when you go
Well,
back-
we're going to look at that in a second. So first what I'm going to do is I'm going to look at, okay, what if it's empty? Okay, well now what if the first value that I'm trying to insert is to the left of the first link, right? Okay, now the other case is, what if the value that I'm trying to insert is 35? Where would that go? Goes all the way to the right, right? So that means now if my last data is less than the new value, that means I'm going to insert right. Since this thing is already in order and this last one is less than the value that I'm trying to insert, that means I have to insert it all the way to the right. So that means I just call my insert right, right? So I have handled now the case of how am I going to insert it at the beginning, how am I going to insert it at the end, how I'm going to insert if it's a new one. So what's left is how am I going to insert if it's, let's say, this one. If I want to insert somewhere in between, either here or here, how would I do that?
Would it depend on the value that you insert?
Sure. So the way it will work is, and again, you want to come up with some kind of a, come up with the idea for your algorithm before you actually, tackle the problem. Otherwise, it's just going to get really messy. Okay, which is the kind of the solution that you're seeing posted online. But I'll improve it. I'll draw some new pictures. It'll look beautiful. Okay, so anyway, so the next thing is basically, all right, so let's say we're inserting the number 25, right? Okay, so if I'm inserting the number 25, where's that going to go? Right here somewhere, right? So what I could do is I can tell it, okay, why don't we look for any value that is greater than this, right? So I'm going to start this in the beginning. First I check, is 25 less than 10? Nope. Is 25 bigger than 30? Nope. So I'm not going to insert first, I'm not going to insert last. I have to stop somewhere in the middle, right? Then I go, okay, all right, start current at first, then keep going and keep going and keep going, and stop at the one where you can do it either way. Let's see how I did it. I said if my data is bigger than the new value, right? So this is where I'm going to stop, right? I'm going to stop at the one before this one, or maybe at this one. and then I'm going to insert before it. Okay? So basically, if any of my linked datas are bigger, if any linked data is bigger than my new value, I'm going to insert before that link, right? That's the idea. That's how I'm going to do it. Okay, so the actual insert ascending, to write this thing, this pseudocode that I have in here, if it's empty, I insert left or insert initial. Else if the first data is bigger than the new value, insert left again. Else if the last data is less than new value, insert right. We already got this. Now, let's imagine how this is going to work. I'm going to make a new link. This is my link 25. I'm going to make current is equal to first. I'm going to tell it go on while current is not equal to no. And current.next data is equal to new value. So what I'm going to do is I'm actually going to stop, if you notice this one here, current.next data, and of course the C++ syntax is slightly different. You got to draw the little arrow instead of a dot, right? Same thing though. Okay? So current.next data is greater than new value. So what does that mean? That means that where is current going to stop looking at this thing here? Is it going to stop here or is it going to stop here?
Gonna stop at the 20, right after?
Yes,
Yeah.
yes. If I'm saying current.next data, that means I'm referring to this one here. So if this data is less than or is greater than the one that I'm trying to insert, stop here. So the current is going to stop here. Okay? Then what do I do? Then, all right, and I kind of, messed up the order of things for the Java class, but I put the letters in here so you know what's first. So it's A, B, then it's C, then it's D. Okay, but let's look at this. So I have new link previous is equal to current. All right? So remember, I am trying to connect my new link to this one. Okay? So that is, actually, sorry, that's a previous. So I'm connecting my new link, which is going to go here, to this one that is the current one. Okay? So that is the new link previous is equal to current. So I change that. Then I say new link dot next is equal to current dot next. Well, remember, this is my current dot next. So if I'm going to be inserting a link here, I need to connect it to the current dot next, right? So that's the purpose of this one here. New link next is equal to current next, right? And new link previous is equal to current. So now I have basically set up the thing in green and the thing in yellow. So my new link is already set up. We have done the connections for it. Okay? Now the next thing is we're going to do current.next is equal to new link, right? So that means that I'm going to connect this one here to my new link. So I break this connection here and I establish a new connection to my new link. And I'm supposed to swap them. That's right, because then I lose my current. Because then the next step is I have to say current.next previous is equal to my link. Actually, I think they will work both ways now that I think about it. Maybe that's why yours was working. Okay? Yeah. Anyway, let's just say it. Let's say, okay, so the first thing is, let's go with the consistency. So current.next, what is my current.next? What's the L3? Right? So I'm going to have to tell it current.next previous. Is that what I'm doing here? Current.next previous. So in other words, I'm telling it this previous here is going to change from L2 to my new link. Okay? That's what this is. Current.next previous is equal to the new link. So I have updated it here. The next one is current.next is equal to the new link. And now I have to just connect this one here. I'm changing the next here to the new link. And then it's done. Okay? The reason I don't want to change the current.next first to the new link is because as soon as I change current.next to something else, I lose track of what my L3 is. If I connect this one to the first link first, I no longer have a reference to this one. Okay? That's why the order of this matters. Okay? So bottom line is, when this is all done, right? So what I like to do is, I like to draw the thing. This is what I did. So I draw the thing. These are my links. My current is going to move down until it stops right here. Right? And then what are the things that I need to change? I need to change this one. I need to change these two links here. And I also, by changing this one, I'm going to change the other one also. I'm going to be changing L2. Right? So when it's all said and done, it will look like this. Okay? I will redraw this picture for this class. I'll go in there and I'll throw that for you. Okay, I swear I thought I had it, but now it's not there.
Did you memorize the stuff off the top of your head?
Do I memorize
Can you
it?
write this without even looking at you?
Yes. I can write this without looking now. But it wasn't like that until I did it several times. Right? And the only way for you to make it easier for yourself is just draw out these, graphs or diagrams or whatever you want to call them. Okay? So this is inserting the business, right? Inserting and deletion is it will be different, but idea is pretty much the same. All you have to do is let's look at the delete first and last. All right? So what I like to do is I like to say, okay, well, this is what I'm starting with, right? All right, so initially I have this scenario right here, and then we're assuming we're removing the last one, right? So the first thing I have to do is I have to change this one here. So if I'm going to be deleting this, what's going to happen? The next one here is going to change to null, right? That's this here. The next thing that I have to do is I just have to move the last. I have to tell it, okay, we'll move the last from where it used to be, one to the left. So in other words, you just say last is equal to last previous, and now the last is moved here. Okay? Yes, if this was not Java, then you also have to have a delete statement in there so that you can actually delete that one. Okay? So you can do that, and I'll redraw it for you. And this is remove left, right? So this is my scenario. I'm starting with this. I'm trying to remove this one here. Right? The only thing I need to change is I'm going to need my first to the right, and I have to reestablish, I have to tell it this previous here is equal to null. Right? So first dot next dot previous is equal to null, changes this, and then first is equal to first next, moves the first one to the right. So deleting links, and of course you got to do the delete statement in C++ in order for it to really delete the link. But that's basically all you got to do. Okay? So that's that. The next thing is deleting somewhere in the middle, right? And this will work with when you create your delete any value, right? What you're going to do is you're going to look at, okay, is the value that I'm trying to delete the first? And again, actually, we should do it like we did it with the insert. Is it an empty list? Because if it's an empty list, I don't delete anything, right? Otherwise, is the value I'm trying to delete the first one? Well, then just delete left. Is the value I'm trying to delete the last one? Well, then you just delete right. And if it isn't any of these three, then we got to delete somewhere in the middle. Okay, here's the middle situation, right? For the middle situation, all we got to do is we have to tell it this link 1, instead of connecting to L2 is going to have to connect to L3, and then this link L3, instead of connecting to L2 previous, we have to change L2 to be equal to L1, right? So I like to draw it like this. So these are the two things I need to do, right? If I'm starting with this, the only thing I need to change is this field right here. This is going to change to L3, and the other thing that I need to change is this one right here. This is going to have to change to L1. Now that I know what I need to change this to, I just go and I write the actual code, right? So the first one, to change this one from L2 to L3, I say current dot previous dot next, right? Since current has stopped right here, I'm telling it the current previous next, which is this field right here, is equal to my current next, which is the L3. So now I have effectively changed next from L2 to L3. The next step is I need to change my previous L2 for link L3 to be L1. So I just say current.next.previous, which refers to this field right here, right? Since this is my current current.next, current.next.previous refers to this field, and now I'm changing it to be equal to my current previous. What's my current previous? L1. Right? So if you have written it, it becomes very easy to visualize this. And if you haven't, good luck. Okay, it'll be infinitely more difficult.
So
Okay.
doesn't that just delete on its own because it's Java? Like it'll just
If this is Java, then it's deleted. But if it's a C++, then we have to say delete current. Now that frees the memory address for the current and the memory address for L2, since they're both pointing to the memory
Do we do
address.
that
Same.
before this part?
No,
You do that.
because you need the current in order to
Oh.
establish these connections.
Oh, I see.
Right? You cannot delete the current before you establish the connection. Otherwise, the list is broken.
Okay.
Yeah, you broke the list. Okay, and this is for let's say this is. I guess I did it twice. It's so nice I did it twice. There you go. So there's two pictures. Yeah. So I'll redraw this for the C++ class. I'll throw it for you in there. You're gonna see it. It's gonna be beautiful. You're gonna get like a little tear in your eye. It'll be awesome.
It's already got Halloween theme, all these little tombstones.
Yeah, there, thank you. Yeah. Yeah, I'm getting you ready. Okay, so that's what you have to do for this week's bundle of fun. And let's go back to, where was I? Week 9, no. That's Java still, 46. So double link, double-ended list. All right. Maybe I threw in the solution in there. Nope, I didn't. Okay, maybe I threw it in there somewhere. Nope, I didn't. Oh well, there will be a nice, beautiful solution. So anyway, what do you have to do? Implement a double-ended, double-linked priority queue. You should be able to remove both first and last. Each link has a next and previous. Priority links are always inserted in order, right? You should be able to show the list forward, going this way, and you should also be able to show the list backward, starting. So if you start from the first, you should be able to go all the way to the last. If you start from the last, you should be able to go all the way to the first. You want to do that because if you're not able to do that, then maybe you didn't establish all the connections the right way. You could have a list that's all set up nice and beautiful to traverse it from first to last, but maybe you didn't establish the backward connections the right way, and then going from last to first is no good. Okay? Huh?
You just write a loop.
Yeah. It's gonna be lots of loops, right? And then there's a display. You were asking me what was that stuff that I was showing you?
Yeah.
All these here was a clever way that I implemented to show the pointers, right? So this is my so I have two links here, right? These are my two links, right? So this is the memory address of the first link. I gotta fix this a little bit because it looks all weird. Basically, it shows you what's the next, right? So what is the field for this is my link. This is the memory address of the self. This is like the object, the link, the memory address for the link itself, right? This here is next, which is the pointer that it has for the next link. And if you see this number here matches this number here, right? So now I have basically shown you that visually that you can, that's the purpose of this right here. Okay? So I'm showing you the data, right? The data is this first number right here, right? Then I'm showing you previous, right? Previous is going to be this number or this number. This is the null, right? If you haven't connected, the previous for the first link is null, right? The next for the last link is null. Okay? The last link links to the previous, and the first link links to the last, right? That's what this thing is showing you, right? So I have my ampersand data. Actually, ampersand data is just the memory address for my data, and then there's my next. Okay, so previous, next, and then the data. Okay, you don't have to do this. It's just for a little extra, clarity. So, question?
Can you go back to the main?
Main.
It was up near the bottom, I think. Above that, right there.
Yeah.
So, let me see if you actually have it. What I've run past is on some of the, I don't see it here, but on some of them, you see you have the dash greater than, which kind of takes the place of the dot assignment, but in some places I still see the dot.
The dot
So
is,
when do you use this versus the dot?
one is, you use one if you do ampersand. Remember in C++, there's two ways for you to refer to a memory address. Well, actually, there's like a million ways, but two of them. One is with the asterisk. With the asterisk, you create a pointer. So the question was, when do we use the little arrow here instead of a dot? So Java always dots, right? Makes it easier, but in C++, since there's like 50 different ways to do the same thing, you could use the dot and you can use the little arrow. If you create a pointer with an asterisk, then you have to use the arrow. If you create a reference variable, which is the ampersand sign, then you can use the dot. But then that kind of changes the syntax of how.
I've seen it without the ampersand previous to that, so there must be.
It might be because, where is that? Where have you seen it without?
I'll take it offline with you. I'll have to
Yeah,
read it.
you got to show me. But if you're ever using instead of a dot, instead of this arrow, you're using a dot. That means that you're working with instead of a pointer, you're using a reference variable. But it's basically the same thing. So you could rewrite this whole thing to look almost exactly like Java. Okay. And by the way, I do have a solution in there. It's not the prettiest solutions of all. So I will, I'll have to, reduce the code on this a little bit. Okay. Any questions? Isn't data structures fun? Oh, nice. I get a thumbs up and very enthusiastic. Okay, cool. I love it. Okay. So, yeah. That's pretty much all I have. And what did I want to tell you? Yeah. This class is so freaking awesome. I'm doing such a great job with it that, wait, that's not it. That I'm actually like one of the students who's in my data structure class, in the Java data structures class, was asking me this morning, can I forward your videos to the CSUMB students because they're taking data structures and they're lost, and yeah, we like your videos and blah blah and all that good stuff. So there you go. Yeah, if you want to feel at liberty to send my links, spread the love. My YouTube channel, that's the deal. Okay, so that's all I have for today. I'm gonna go to the office now and I'm going to use some extra color to draw some pictures for you. Okay, if you have any questions, come see me, send me your emails. You know the drill. Thanks for coming. I'll see you next week.